Hey guys, we're here at Pro Tuning Freaks. We're going to go through some of the features in the next few episodes on the port fuel injection, nitrous, methanol, line lock, all these things that can be configured on the DME in your map. We'll walk through them, show you what they're about, how to configuring it either by yourself in map configuration or working with the tuner to get it dialed in. First one that everybody wants to talk about is port fuel injection. We'll start out by showing you a DI OEM fuel injector. There are some upgrades out there that add 30%, maybe even 50% more fuel than the factory injectors, but eventually there's a point where some of you may want to go past that in terms of your builds, and a need for secondary fueling comes into play. REV2 provides an integration with the DME. Literally, once it's installed in the car, it almost behaves like a relay. It has no brains of its own. You don't tune the REV2 like you would, say, a Max ECU or any other standalone that people were putting in these cars to get port injection or any of the other features going. Once it's installed, it sits there as a black box in your engine bay. All the tuning is done from a laptop basically connected to the factory engine computer, just like you do for any other tuning that you've done up until now. Coming back to the injectors, once these are maxed and you've got the REV2 installed, you're putting in a port injector, which looks something like that. This is an injector from Injector Dynamics. It's an ID 1300. Usually this one will max you out on the S58 around 1200, maybe a little bit less than that. With these injectors, you'll want to go up to 1700. When you get to 1400, 1500 wheel, maybe you even go to a 2600 Injector Dynamics. There's other companies that make them as well. Basically what I'm getting to is once the DI system is maxed, you've got supplemental fueling coming through a secondary rail that sits on the intake manifold, and these guys plug into that rail and they plug in on the bottom into the intake runner. From that point forward, once everything is installed, you're going into the tuning to set that up. In the actual mapping, you would go in and you have the ability to set up those injectors, their flow characteristics. These are usually provided by the manufacturer. Injector Dynamics is really good with this. It's all available on their website. We may even add the drop downs for these various popular injectors out there, so it's easy for you to choose it in the drop down like we do for map sensors, for example. Once you've set up your injector flow curve and injector characterization for fuel pressure differential versus battery voltage, all of that stuff is in there, your injectors are configured. And then you get to choose between 4 different port injection control strategies, and these are all configured on the DME. You have the ability of using the manual sort of setup where you're using the injector duty cycle to set them up. There's also an automated sort of way that looks at the fuel mass that the DME is calculating that is required to be fueled to the motor. Based on the load, based on various running parameters in the car, different fuel mass may be required. So depending on your boost levels, DME is non-stop calculating this based off of the O2 sensor feedback as well, off of the fuel trims. You're getting different fuel mass calculations happening at the DME, and what you're doing in the map, you're telling the DME portion of that total fuel mass will go to port injection. You're sort of splitting it between DI and PI, and it's all integrated into one algorithm for fueling the motor for a given load. So what you've got is basically a table where you can set this up for the PI-DI split. What we added for flex fuel and handling basically ethanol concentrations is similar to what we did for flex fuel on DI-only setups before CustomROM V2. So in V1, we had fuel target tables that are there for gasoline or 0% ethanol and 100% ethanol, which we call flex fuel. The two tables work together using this blend logic. It's a table where you can set up for a given amount of ethanol, you transition from the gasoline lambda targets to full ethanol 100% lambda targets. And the blending in between those is happening on the DME side, which basically falls into the functions and calculations to the fuel mass that I initially mentioned. So as your ethanol blend is changing, your fuel mass is also changing automatically, which then falls into place into these two tables and the blend factor that you've set up between them. So it's a nice way to do port injection compared to what was done before with duty cycle or pulse width somebody used an AIC, I believe those were done in pulse width. I don't know if they had a duty cycle view of the table that they had, but it's nice not to deal with fixed duty cycle table setup, because if you've tuned your car on the dyno and it was hot on that day, and you're driving your car in the winter and you're trying to fuel the car again with port injection, duty cycle for a given boost may not be enough at that time. You may need more duty cycle because it's not in closed loop. Same thing could happen if you tuned your car, got everything done in cold weather, and then took it out on the road or at the track and you ran it in very hot weather. Now that duty cycle may be sending too much fuel out of your secondary injectors and you might be running too rich. So with duty cycle in there, things are workable, but you end up sort of tweaking things nonstop. So this fuel mass automated calculation-based port injection takes that to the next level, where a lot of that is automated. You let the DME calculate the fuel mass based on all of these conditions, and then just a percentage split is taken from that and sent out the PI side. And then you can do flex fuel on top of that and do blend factors in between the gasoline setup and 100% alcohol setup, whatever alcohol you might be running in your tank. That goes through some of the setup in terms of tables. The really cool feature is the safeties that we have. From what I know, there's nothing currently like it out there in terms of custom safeties built into the DME when it comes to port injection or any of the auxiliary connections for outputs that we have. For port injection specifically, you've got DTCs that are fully configurable. So if your direct injection injector, let's say, disconnects or dies, if there's a misfire on cylinder 1, DME will do different things depending on what happened. But in a nutshell, your cylinder 1, for example, DI injector is off at that point. Either DME wanted it off or simply short-circuited or whatever the reason may be. If you're under full boost and at that point in time, that particular cylinder requires a certain amount of fuel, with just having a standalone on your engine isn't aware of what the DME is doing, it may continue fueling that particular cylinder with the duty cycle that you set up. Obviously, this will cause a lean condition. At best, you'll have a misfire and nothing happens. In the worst case, you may have a hole in your piston. So in the DME, what we have now is we're hooked into these functions that trigger these OEM safeties for misfires, for line disconnect on an injector or whatever have you. In addition, we gave it the ability to also cut the PI injector at that time. This is fully configurable. There are tables that are called FIDs or functional IDs, and the table is about 18 columns wide. And each of those can be set to a 0 or a 1. And what that means is the first 3 you'll see in the map editor, we've got the ability for you to cut nitrous solenoid, to cut the REV2 duty cycle output to the max solenoid, and you've got the ability to cut the OEM. If you're running the OEM turbos or hybrid turbos that run the electric wastegate, you can cut that as well. So all of the power adders that the REV2 is adding on the car, in the moment that you have an issue with any of your injectors, you can cut those same injectors on the PI side. And we've also included the ignition coils into it. So typically on this DME, if the DME cuts the DI injector, it'll also cut the coil. But we're giving you the ability to configure that, and you can cut just the DI injectors, you can cut just the PI injectors, you can cut just the coils. So the decision on that is on the tuner that you're working with in terms of how to set up your fail safeties in the best way. Other than those DTC codes that we have for port injection, that we have for PI, DI injectors, we also have safeties there for if your flex fuel sensor is disconnected, you have the same sort of setup with a custom code that you can configure. If your low pressure pump is not providing the needed minimum differential fuel pressure, then you can have a code set, and you can also do the same type of setup where you kill all of these power adders or any of the other things that I mentioned before. So one last thing about the actual install. I mentioned this in the installation video, but I want to go through it in a little more detail at this point, as the questions keep coming in about the need for hooking in the exhaust flap for port injection. So this is that long piece of harness that goes from the front of the car to the back. It is optional, but people have been asking what's our preferred way of controlling port injection, and it's this. Both of them work. In terms of functionality, you won't really lose anything with FlexRay. It guarantees delivery of these messages. There's been discussions online that I've seen. People have been sending screenshots about whether FlexRay is guaranteeing this delivery, how are we doing it with controlling a port injector and all of that stuff. FlexRay, as opposed to CAN bus, guarantees message delivery, and it does so through the static segment, which I've mentioned in the video before. There's also some information on our website, but there's a lot of information if you Google or use ChatGPT to ask, on the advantages or disadvantages of using FlexRay, CAN bus, whatever protocol that it may be, and compare that to just pulsing an injector. So you've got all these protocols on one side. They work different ways. All of that's on one side, and then you've got just plain pulse, direct pulse off of the DME, port injectors. If you have these as your primary injectors, they're just pulsed. And REV2 also pulses that injector with pulse width modulation. So what's a better way than just have the DME pulse this injector? Why have this overhead of any communication protocol on top? So that was our idea for adding this. We found two outputs that we could repurpose for this, and the exhaust flap, in case you don't need it, in case you have disconnected it, you don't care about these flaps, you like your exhaust loud, you have a race car, you want to use this one as the preferred one, as there's no communication protocol overhead. When the DME pulses the output for the flap, it goes to the board, and in that moment in time, the exact same pulse is being pulsed to the injector. So it's literally the closest thing out there to pulsing the actual injector directly. Thank you for watching this episode. Make sure to like and subscribe, and we'll see you in the next one.